The act, method, or overall process of detecting and measuring electric current is referred to as current sensing. Accurate current measurement and management are becoming extremely critical in pursuit of carbon neutrality, not only to improve efficiency but also ensure safety, driving the demand for current sensing circuits capable of supporting these requirements. In the automotive sector, where electrification continues to progress, large currents flow through safety-critical systems such as traction inverters, batteries, and electric power steering. In the industrial equipment field, effective current management and enhanced charge/discharge efficiency are essential to support the growing adoption of renewable energy and expansion of energy storage systems. In the consumer sector, use cases and objectives are expanding beyond home appliances and AV equipment to include energy optimization, driven by the growing adoption of ROHMs and IoT devices. Current sensing can be broadly divided into two types: magnetic field detection and resistive detection. Magnetic field detection includes both core-based and coreless approaches, while resistive detection typically utilizes op-amps or current sense amps paired with shunt resistors. ROHM offers a comprehensive lineup of both op-amps and resistors. Op-amps provide design flexibility in terms of gain and frequency bandwidth, while current sense amps simplify the design process. Integrating shunt resistors with semiconductor technology allows ROHM to deliver effective sensing solutions. In op-amp development, ROHM places a strong emphasis on improving noise performance, offering an ultra-low noise series designed to minimize noise generation along with a high ME tolerance lineup that provides strong resistance to external noise. ROHM low-noise op-amps deliver the industry's lowest noise levels among CMOS op-amps, making them ideal for amplifying sensor outputs with minimal fluctuations caused by internal noise. High EMI immunity op-amps offer exceptional noise tolerance, reducing the complexity of noise design by eliminating output fluctuations across all noise frequency bands. The EM Armor op-amp series achieves electromagnetic noise immunity with minimal output voltage fluctuations across the full noise frequency spectrum during international noise evaluation tests. ROHM provides an extensive lineup ranging from low-power models to high-accuracy, high-speed types, and continues to lead the industry by expanding its portfolio of high-performance products. For customers requiring even greater detection accuracy, ROHM recommends current sense amps. In conventional configurations that combine op-amps and discrete components, variations in the external resistors can significantly impact gain and offset characteristics, while current sense amps feature precisely match the internal components within the IC chip to ensure high gain accuracy. Gain accuracy comparisons show that a plus or minus 2% error can occur even when using external high-accuracy chip resistors, whereas ROHM current sense amps maintain an error of plus or minus 1% or less over the entire temperature range. In automotive applications, disconnecting the battery line during power generation can cause a high voltage surge, which may damage the ECU and other electronic components. To prevent such failures, automotive ICs must support high withstand voltages ranging from 36 volts to 80 volts. And since vehicles do not have a true ground reference, accidental reverse battery connection can lead to negative voltage being applied to the ECU, risking serious damage. Therefore, automotive ICs are also required to tolerate negative voltages down to minus 14 volts. To address these requirements, ROHM offers a lineup of automotive-grade products for 12 volts and 48 volts battery systems compatible with both high withstand voltages and negative voltage conditions. These products cover a wide common mode voltage range. ROHM considers application voltage needs by offering one-channel current sense amps and 3 common mode input voltages, including 40 volts and 80 volts variants ideal for automotive use, as well as 2-channel models without a ref pin for unidirectional detection, suitable for industrial equipment. All products are available in industry-standard packages, enabling easy replacement. ROHM resistors, its founding product, have been in use for many years, earning the trust of customers worldwide. Shunt resistors used for current sensing are manufactured using in-house metal processing technology, allowing ROHM to deliver products with characteristics tailored to customer requirements. For example, ROHM consistently develops products with industry-leading specifications, including ultra-low profile packages and superior heat dissipation. ROHM is actively enhancing its technologies and product portfolio to meet the growing demands for compact size, high power, and enhanced reliability, From high-power series and compact high-heat dissipation models to thick-film variants covering a wide resistance range, while also focusing on the development of high-performance shunt resistors. Because magnetic field detection types rely on large sensor cores, switching to resistive detection methods for current sensing can significantly reduce both footprint and volume. Moreover, with resistive detection, integrating the shunt resistor directly into the power module can further reduce application size and weight. We invite you to consider ROHM solutions for your next design.